In order to make the inside cut, we're going to loosen the set screw, place the pin in the center hole again, and then adjust it in the same manner we did earlier. Lower the router bit, bring it up to the mark, set your set screw. You could spin the router bit just to double check that you're exactly at the cut line. Make sure you're on the X side, the scrap side of your cut, because this is where you can make your mistake and be on the wrong side and be 1/4 inch off on your cut. And then we'll repeat the process again. Again, we'll rotate the router back 1 or 2 revolutions in order to reduce the tanglement of the cord. Start the router up and plunge. Another thing that you do when you're starting your cut, instead of plunging straight down, if you turn it very slightly as you're plunging, it'll keep the bit from burning up a little bit. It gives it a little bit more area for the dust to kick out, and then it helps make your bit last a little bit longer. Once you finish your cut, you're going to want to hold everything still until the router comes to a stop and allow the plunge to plunge up after the router bits stop rotating. Assuming that nothing's changed, your router height and bit height haven't shifted, you'll be able to have your router pad or your router ring come out exactly like you planned. Just an example as to the precision of using a router jig in this technique, you could see that we have these small rings that are based around the 1/4 concentric, and they all fit to each other. And also we have small thin aluminum rings can be routed out with a router also, and you can have some nice trim rings and things like that that go around tweeters and mid-ranges, even subwoofers. Thin aluminum or acrylic or ABS that you can cut, and this technique makes the pieces exact, fit perfectly, and it's repeatable. Typically, if you're going to cut aluminum, the thickest you'd want to go is about 1/8 of an inch, because aluminum is hard on the router, and then you want to use the proper bit, which would be probably a straight cutting bit rather than a spiral bit to cut aluminum. Just to show you the technique and how to cut rings of this precision around the smaller things, I'll show you what you're going to need is a digital caliper. And then there's a little technique and a little bit of calculation that you'll want to do. When you're making precision rings out of thinner materials, you're going to have to use some thin double-sided tape like this stuff here from Mobile Solutions. It's a thin masking tape, and what you're going to want to do is use quite a bit of it so that when you cut through, that the ring doesn't move and gouge the edge of your ring. So you want to pretty much cover the entire surface with masking tape. With the smaller rings, when you're done, it has a really small surface area, so if you don't use a lot of double-sided tape, the piece will move on you and then you'll have to make another one. And because this material is so thin, and the pin on the circle guide is about 1/2 an inch deep, you're going to want to stick it onto a scrap piece of backer and push it on firmly. Mark the center. Another thing you want to do is use a mechanical pencil rather than a standard pencil when you're doing these kind of maneuvers, so that you have a fine edge and you have more precision. Find your center. Since we're using ABS here, you want to use a 9/16 inch bit. Drill your center. And this is where you'll use a set of digital calipers rather than the center finder ruler to make your measurements. In this case, let's make a ring that is 1.5 inches in diameter exterior and 1 3/8 interior diameter. So the ring will be 1/8 of an inch thick. When using the calipers, what we need to do is accommodate for the thickness of the 1/8 inch guide pin. And what you're going to do is measure make sure that your router is off and unplugged. Plunge the base so that the router bit is sticking up slightly. And then what you're going to do, of course, your outer ring first and measure in between the guide pin and your router bit. Now, since the guide pin is 1/8 inch wide, the decimal equivalent of 1/8 inch is 0.125 inches. Half of that is going to be 0.0625 or 0.063 when you round up.